Sketch and analyze the graph of each function. Describe its domain, range, intercepts, asymptotes, and behavior, where the function is increasing or decreasing. So 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. And 2 to the third is up here at 8. And then, like 2 to the negative 3, that doesn't make anything negative. It's 1/8, because 2 to the third is 8, and that negative power sends stuff down to the denominator. So the more negative we make it, the closer to 0 it's getting. So it's leveling off to 0 on the left side, and on the right side, we're shooting up to infinity. So there's the graph. We do have this horizontal asymptote at y equals 0. Describe its domain. So we'll answer all the questions now. Domain. Negative infinity to infinity, you can raise 2 to any power. The range for this one is 0 to infinity. This is leveling off at 0. The intercepts. We have a y-intercept. And that's at, y-intercept. I was thinking asymptote. 0, 1 is the y-intercept. Asymptotes. Y equals 0 is an asymptote. Ending behavior. We describe ending behavior with limit statements. The limit as x approaches negative infinity of f of x is equal to 0. So as the function goes to the left, we're leveling off to 0. And then the limit as x approaches infinity of f of x is equal to infinity. It's shooting up to infinity on the right. Where is the function increasing or decreasing? As you go left to right, this function is increasing on its entire domain. So there's no place where left to right this function decreases. Evaluate. Log base 2 of 1/16 says, what do you raise 2 to get 1/16? Well, 2 to the 4th is 16. So 2 to the negative 4th must be 1/16. So the answer is not 2 to the negative 4th. This evaluates to just the number negative 4. Now this says 16 to what power is 4? That's 1/2. It's square root of 16 is 4. 4 to the 0 is 1. And then if you take the natural log of e, those cancel, and the answer is just 3. So if you have log base 5 of 5 to the 6th, that evaluates to just 6, because those bases are going to cancel each other out. Condense. First thing I would do is write this with powers, so x squared plus natural log of y to the 3rd minus natural log of 16x to the 4th. So when you bring that 4 up there, 2 to the 4th is 16. Now addition goes to multiplication, so we have natural log of x squared y to the 3rd minus natural log of 16x to the 4th. And then minus goes to division. So natural log of x squared y to the 3rd over 16x to the 4th, and the x's will cancel. We have natural log of y to the 3rd over 16x squared. This one factors. E to the x times e to the x is e to the 2x. And then we have minus 5 and minus 2. So then e to the x minus 5 has to equal 0. So e to the x equals 5. And then you take the natural log of both sides. And when you take the natural log of e to the x, they just cancel out, and you're left with x. Then we have e to the x minus 2 equals 0. E to the x equals 2, so x equals a natural log of 2. And when you take the natural log of e to the x, that cancels out. Identify all angles coterminal with the given angle. Then find and draw one positive and one negative angle coterminal with the given angle. So here's all of them for 191. You'll have 191 plus n times 360 degrees. Assuming n is an integer. N can't be like 1/2 or 3/4. Has to be an integer. Then how about one positive? We have 191 plus 360, which is 551. And then we're supposed to draw that. So here's 191 right here. It's 11 degrees past 180. So now what we've represented is just now we're just going all the way around one more time. So that should be 551. And then we have 191 minus 360. So 191 minus 360. And that's negative 169. Negative 169 degrees. And so that should be, here's 11 degrees past 180. So negative 169 should be right there. It's got to be the same place because we're saying it's coterminal. And then with radians, we have negative 3 pi over 4 plus 2 pi n. That would be all of them. Now I need a positive and a negative. Negative 3 pi over 4 plus 8 pi over 4. That's plus 2 pi using common denominators. So that is 5 pi over 4. Now I'm asked to draw this. Well, negative 3 pi over 4 is actually right here. So we need to make that 5 pi over 4. So we're going this way. And then we have negative 3 pi over 4 minus 8 pi over 4. And that's negative 11 pi over 4. So this right here, this would be negative 3 pi over 4 right there. We just have to go all the way around. That should be a negative 11 pi over 4. Ew, I kind of did this linear, didn't I? That's how I roll. Find the area of each sector. The area of a sector is equal to 1/2 r squared theta, where theta must be in radians. It doesn't make sense to take the radius times degrees. It makes sense to take the radius times radians. So we need 1/2 13 squared times 65 pi over 180. And that's turning the degrees into radians. 0.5 times 13 squared times 65 times pi divided by 180. So 95-ish. 95.862, and that's going to be centimeters squared. Find the exact value of the 5 remaining trig functions. There's probably a couple ways we can do this now. We could use 1 plus tangent squared equals secant squared. And then we could use sine squared plus cosine squared equals 1. But it'd probably be quicker just to use a right triangle. So here's theta right there. Now it says sine is positive and cosine is negative. So if sine is positive, this is going to be 4. And that'll be the negative 3. I got to get negative 4/3 out of there. I could probably go with either way and get negative 4/3, but I got to follow kind of the criteria, right? So this is a 3, 4, 5 right triangle. We could use Pythagorean theorem to find that hypotenuse. And now we just have to find the other 5 trig functions. Well, here's what I like to do. I make a little template, and I usually include the given also. It's only one more statement. There's the cosecant, there's secant, which is the reciprocal of cosine, and cotangent. So sine is opposite over hypotenuse, that's 4/5. So this must be 5/4. Cosine is negative 3/5. So this must be negative 5/3. This is the given. Negative 4/3, so this must be negative 3/4. Find all solutions of the given triangle if possible. If no solution exists, write no solution. Round side lengths to the nearest tenth and angle measures to the nearest degree. So what I do is I usually put the given angle down on the bottom left here. This is the 24 degrees. The opposite side is going to be the A, which the given is 10. Now if I call this angle down here B, then this must be 24 over here. So we end up with the naughty word. angle side side, and in the books they do side side angle so they're not writing naughty words all over the place. So this is the ambiguous case, so we have to decide, do we have 1, 0, or 2 triangles? And we're going to compare 10 to this height right there. So the sine of that 24 degrees, sine of this angle is opposite over hypotenuse, which is the height I want over 24. So 24 sine of 24 is the height that I'm going to compare 10 to. So 24 sine of 24. And I got to make sure my calculator is in degrees now, because everything's in degrees. It is. So it ends up being 9.76. Well, that 10 now is longer than 9.76, so there's a triangle. And I can also swing this over, since 10 is less than 24, I'll have this red triangle right here also. So we have 2 triangles. Unfortunately, we got some work to do with 2 triangles. So we have A, B, C, A1, B1, C1, and A1, B1, C1. And this is the triangle we're looking at right now. Right there. This is 24. A1 is 10. And this is 24 for the length of the side. We have sine of 24 over 10. This is the law of sines. Is equal to sine of B1 over 24. So we have 24 sine of 24 divided by 10. Now this is going to be the sine of B, and it better be less than 1. It is. So we can take the inverse sine of that answer, and this is going to be B. And I think it said round angles to the nearest degree, if I remember right. Yep, to the nearest degree. So this is 77 degrees. We can add 24 to that and minus that from 180. 79 degrees. Let's call it 79, rounded. Well, now we need a law of sines one more time. Sine of 24 over 10 is equal to the sine of 79 over C1. 10 sine of 79 divided by sine of 24, which is 24.1. So 24.1. Well, now we have this red triangle to deal with right here. So we have angle A, B, C. So A2, B2, C2. And this usually goes pretty quick. This is 24 degrees. The givens cannot change. That's the whole point of this. So that's still the givens. Those can't change. And we have B here. We know that. That's right there, 77. So this is 77. That's 77. So I need the supplement of 77, which is 103. That'll sound great on the recording. Dang. So 103 plus 24 minus 180. So we do a couple of minus 180s. That's 53. Sine of 24 over 10 equals sine of 53 over C2. 10 times sine of 53. And then divide that by sine of 24. And so 19-ish. 19.6.